In this video, we will be talking about polar coordinates and polar curves. So now we're going to be switching to a different system that you may or may not have learned in trig. So we're going to do it here. So far we've been kind of working with the x and y plane. And we're very, very familiar with this. And then this x and y plane, we call it the Cartesian coordinate system. We also call it rectangular. Okay, so many different names. And today what we're going to do is we're going to convert this to something different, which is going to be r and theta. And this is what we call polar. So it's a different type of coordinate system. It's used a lot in areas of mathematics and engineering and all that other good stuff. So we use polar sometimes a little bit better because it kind of gives us a better way to kind of do problems, and then it's useful in calculus as well, especially if you go all the way to Calc 3 and also Calc 2. So so first let me start off with what r here is. So r here is what we call the directed distance. So what I mean by directed is that if we've been kind of thinking of r as the radius, and it is basically the radius, but it can also be directed. So if the radius is negative, it means that it's going in the opposite direction. And here we have theta. Theta, we kind of already know that it's going to be an angle. So it's going to be an angle between the polar axis, and I'll explain what the polar axis is in a little bit. So just giving you a little name. So I gave you kind of an example of what this kind of looks like. So right here on this side, but let me just give you kind of like a little bit of a glimpse of how to draw this. So this little dot here is what we're gonna call the pole. So that guy's called the pole. This line, which is kind of going towards the x-axis, a positive x-axis, is what we call the polar axis. And then finally, if I wanted to graph a point in space on the polar region, then this guy from the pole all the way to that point is going to be the radius r. Okay, and the angle that this makes is going to be theta. Okay, so that's basically what it says. So let me give you a quick example. So let's say I know that this point r theta is in the polar space. And I wanted to graph 3 comma pi over 4. So basically, the way that this kind of works is that these circles are circles of radius 1. So you see this circle, this first circle. This is a circle of radius 1. The next circle is a circle of radius 2. The next circle is a circle of radius 3. So that's basically what these circles mean. So these circles are just of radii 1. So here what it's saying is that the radius is going to be 3 in the pi over 4 direction. So pi over 4 is in this direction, starting from the pole all the way to in that direction is going to be pi over 4. And in that pi over 4, well, I can extend infinitely, but I only want it to go up to a radius of 3. So I'm going to count 3 circles. 1, 2, 3. This point right here represents 3 comma pi over 4. Okay, that's the point that represents. So if I wanted to do 1 comma pi over 12, then I would go in the pi over 12 direction, which is right there, and only go to one circle. This point right here would denote 1 comma pi over 12. Very differently, if I wanted to do, for example, negative 1 pi over 3, then notice that pi over 3 is going in this direction. However, because it's negative 1 and it's a directed distance, what I'm going to be doing is going the opposite direction, which is going to be in this guy, this way. So instead of going forward to pi over 3, I'm going to go backward. And this point right here is going to denote negative 1 comma pi over 3. Okay, so it's a little bit different than the way that we've been talking about rectangular coordinates. Okay, so let's do a couple of examples, okay, to just start a graph. So let's, here I have some polar paper, which will also be available to you on Canvas if you want to practice with it, but you can always just draw it as well. So let's just graph the points. So let's say I wanted to graph a couple of them, 1 comma 3 pi over 4. Let's say I wanted to do 3 comma negative pi over 6. And then negative 4 comma pi over 4. Okay, so the first one, let me call it in purple, 1 comma 3 pi over 4. So I'm going to go in the 3 pi over 4 direction. So here's the 3 pi over 4 direction in quadrant 2. And I'm going to move 1 unit over. So this point is going to denote 1 comma 3 pi over 4. Okay, so that's that point. Now I'm going to look at 3 comma negative pi over 6. All right, so if this guy is pi over 6, that means negative pi over 6 is right below 0, which is going to be this guy. So this guy is going to be negative pi over 6. Now in this direction, how many units? I'm going forward in this direction, and I'm going to go 3 units over. 1, 2, 3. So this point right here is going to represent 3 comma negative pi over 6. Okay, finally, let's do negative 4 pi over 4. So pi over 4 is right here, but we're going in the negative direction, so we're going to go this guy. So we're going to go 1, 2, 3, 4. So this point right here represents negative 4 comma pi over 4. Now notice also that this point also represents 4 comma 5 pi over 4. So if I wanted to graph 4 comma 5 pi over 4, it's actually the same point as negative 4 comma pi over 4. So what that means is that these numbers or these points can be represented in infinitely number of ways. So I can add this guy by 2 pi k many different times, and I can change this continuously from positive and negatives. So usually there's not one solution. There's going to be many different solutions that we can do when we talk about polar stuff. Okay, so now that we kind of get a glimpse of how to graph these guys, what we want to be able to do is kind of convert between Cartesian coordinates and with rectangular coordinates to polar. So I'm going to put rectangular to polar. So how can we kind of convert between the two? All right, so we're going to start off with the rectangular coordinate system. So here's my x and here's my y. So I'm going to start off by drawing array of radius r and then an angle theta. Now this point is going to be represented by x comma y. Okay, so basically what I can do is I can write a triangle 90 degrees, and in this direction this is going to be the y value and this is going to be the x value, kind of the way that we did the unit circle. So if you just kind of look at the theta value, we can see that the cosine of theta is going to be equal to x over r. And we're also going to see that the sine of theta is going to be equal to the y over the r. So I can solve for x, so x is going to be equal to r cosine of theta. And then I can solve for the y here, and y is going to be equal to the r sine of theta. So I can kind of relate the x's and the y's with the r and the thetas using these equations. So these are basically the polar equations. Furthermore, I can also relate tangent of theta as well. Tangent of theta is going to be equal to y over x. And because I know that this is a right triangle, I know that x squared plus y squared is going to be equal to r squared. So these equations are basically the polar equations. Okay, so this is for polar. So to convert polar to rectangular, we're going to use these equations. One of the things to just remind ourselves about tangent of theta is going to be between negative pi over 2 and pi over 2. That is the restriction on the inverse tangent. Okay, so just be aware of that. Okay, so now what we're going to do, let's go ahead and practice converting from rectangular to polar. So let's do this example. So convert to polar coordinates. Okay, so let's start off with part A, 2 comma negative 2. All right, so I have this equation, this coordinate, and this coordinate is in x comma y. Okay, so we know that this guy is going to look 2, there's 2, and then here's negative 2, which is basically what we already knew in the x and y plane. But now we want to convert it into polar. Okay, well, the first thing that I know is let's try to figure out what r is, because I want to convert this to r and theta. So I know that r squared equals x squared plus y squared. Okay, so now I know x in this case is going to be this 2 squared. This y is going to be this negative 2 squared. So r squared is going to be equal to 4 plus 4. R squared equals 8. So r is going to be equal to plus or minus 2 square root of 2. Okay, so notice here that you can kind of choose both of them. So you can remember that these points are not unique. So you can choose either or. It doesn't really matter. It'll give you the same thing. Okay, so I'm just going to leave them both like that. Now let's figure out what theta is going to be. So I can use theta. I know that the tangent of theta is equal to y over x. So tangent of theta is equal to negative 2 divided by 2. So the tangent of theta equals negative 1. So theta is going to be equal to the inverse tangent of negative 1. And when I do that, it's going to be equal to negative pi over 4. Okay? Now, notice here that you can kind of just think about it and be like, okay, well, in this direction is going to be negative pi over 4. Okay, theta equals negative pi over 4. So, well, if I'm going in this direction, that means that the radius should be positive. Okay, so that means that this point corresponds with this point. It's going to be 2 square root of 2 comma negative pi over 4. That would be one of the solutions. Now, let's say I wanted to do the other one. So let's say I had negative 2 square root of 2. That means that in order for me to be on this point, I would have to go the opposite way. And if you think about it, tangent of theta equals negative 1 is also in this direction. That's going to be 3 pi over 4. Okay, so if I'm moving in this direction at 3 pi over 4 and going opposite way, that's another way that you could do it. So negative 2 square root of 2 and 3 pi over 4 is also another point. So any of these 2 points would actually be a feasible answer. Okay, so now let's do one more. So let's say we had 4 comma 3. Okay, so with 4 comma 3, we're going to start off by finding whatever r is. I need to figure out what r. So r squared equals x squared plus y squared. So r squared is going to be equal to 4 squared plus 3 squared. R squared equals 16 plus 9. So r is equal to 5, plus or minus 5. Okay, so notice that 4 comma 3 is going to be here. 1, 2, 3, 4, and then 3. So that's in this direction. All right, so now let's figure out what theta is. Theta is just going to be the inverse tangent of y over x, which is 3 over 4. Notice that in this case, it's going to be a little bit hard to figure out what exactly that is. So one of the things that you can do is just leave it like that. And you can just say that in this direction, the direction of tangent inverse of 3 over 4, you're going to get positive 5. You can leave it like that. Another way that you can do it is just go ahead and just figure out what the tangent inverse of 3 over 4 is. Okay, so 3 over 4. And that's going to be about 36 degrees. I have it in degrees for some reason. Let me go back to radians. So that will be about 0.64 radians. So you can write it as 5 comma 0.64. Okay. If you wanted to do it the other way, remember that it's going that direction. Okay, so the way that I can figure that out is just by adding pi. So you can leave it as tangent inverse of 3/4 plus pi. That's going to give me this direction, and then you can use the negative if you really want to. So both of these would be solutions to that particular problem. Okay, so now let's finally just do the opposite direction too. Let's go ahead and convert to rectangular. So convert to rectangular. So converting to rectangular, let's say we had 4 comma 2 pi over 3. So what that means is that now I want to convert this to x comma y. So what I'm gonna do, this is actually a really, really easy procedure. We can just say x is equal to r cosine theta and y equals r sine theta. And because we already know what r and theta is, all we gotta do is just plug it in our calculator. So 4 cosine of 2 pi over 3, and then 4 sine of 2 pi over 3. And luckily, all of this is in the unit circle, so I can go ahead and figure it out. So I'm going to have 4 cosine of 2 pi over 3, and that's going to give me negative 2. And then the other one is going to be 4 sine of 2 pi over 3. And that's just going to give me 2 square root of 3. So in the x and y plane, it'll be negative 2 and 2 square root of 3. Okay? So in the other videos, what we're going to do polar equations, and then we're going to do a couple of graphing.